Good morning everyone. Myself Kausar Momin, ninth standard, subject Science, chapter number 11, Reflection of Light. In the last lecture, we studied mirrors and types of mirrors. Today we are going to discuss about spherical mirrors and images formed by them. As we know, spherical mirror is a part of sphere. Suppose if I am cutting the sphere from this side, then this will be a concave mirror. If suppose this is a sphere, if we cutting the sphere from this side, then the portion is coming out this part. This is convex mirror. So as per these mirrors, we are having few terms related to spherical mirrors, terms related to spherical mirrors. All these terms we used for drawing ray diagrams and all. So first of all, first term is pole. The center of the mirror surface is called its pole. P is the pole of the mirror in figure. Before to see this figure, I will show you how exactly pole we can define. Suppose this is a sphere. Okay. And if we are cutting our mirror from this side, this much portion we cut it. Okay. After cutting a sphere part, then we are getting mirror which is this way. Okay. Then if suppose this much portion is there, so center of this mirror is pole. So in the diagram you can see this is a sphere, and if this part is mirror, so obviously for this part there is a center, and for that center we are naming it as pole of the mirror. Okay, center of the spherical mirror is pole of the mirror. Then center of curvature. The center of sphere of which the mirror is part is called center of curvature of the mirror. C is the center of curvature of the mirror. What is center of the curvature? Whenever you are considering a sphere, obviously it has a center, and if you cut it this much portion for spherical mirror, then definitely this part also has a center. Okay. Apart from that, we can say the same way here. C is the center of curvature of that mirror. Clear? Next, radius of curvature. The radius of the sphere of which the mirror is part is called radius of curvature of the mirror. The length CP or CA in the figures is the radius of curvature in the mirror. You can observe in this diagram radius of curvature, that is, as we know, the center point, the joining point, center point, and this point, we can say it as radius of curvature. Now next is principal axis. The straight line passing through the pole and center of curvature of the mirror is called principal axis. PM is the principal axis of the mirror. You can observe here principal axis, the line which is passing from center of the sphere. This line which is MP, this is called as principal axis, or you can say it as principal focus. Next is principal focus. Incident rays which are parallel to the principal axis of concave mirror after reflection from the mirror meet at a particular point in front of the mirror on the principal axis. This point is called as F, which is principal focus of the concave mirror. What is this? How we are going to recognize concave mirror? This way. If this is your concave mirror, this is the reflection part, this one is the principal axis. Obviously, if the incident rays, this one is the center of sphere. If incident rays which are parallel to the principal axis and after reflection they are passing through a specific point, and that point comes on principal axis itself, and it is between center of curvature and pole, so that we are calling it as principal focus. We will discuss in detail these things also. In the case of convex mirror, incident rays parallel to the principal axis after reflection appear to come from particular point behind the mirror lying along the principal axis. This point is called as principal focus of convex mirror. How convex mirror? Suppose this is convex mirror and this is the reflection part. Okay, this one is the principal axis. If incident rays falls on this mirror, then where you are getting its principal focus? Obviously center of curvature is here, see, and obviously between center of curvature and this pole is your principal focus. So somewhere you will feel that these rays are coming from behind the mirror. Next is focal length. The distance between pole and principal focus of the mirror is called focal length. This distance is half of the radius of curvature of the mirror. You can see in this diagram the distance between focus and pole. This is called as focal length, and definitely this much is radius. So between this radius we can say it as it is exactly half of the radius of curvature. So we can write focal length is equals to radius of curvature divided by 2 also. Next discussion is for drawing the reflected rays. Whenever incident rays falls on a spherical mirror, either concave or convex, how the reflected rays are coming out from the mirror. So that thing we have to discuss in this paragraph. How to determine the direction that incident ray will take after reflection from a spherical mirror. In figure, MN is a spherical mirror. Here you can observe that in this figure we are taking a spherical mirror which is MN, this one, and whenever these lines are there, that is what? Reflected part. And ray AQ is incident on it. CQ is radius and therefore is perpendicular to the mirror at Q. Thus, angle AQC is the angle of incidence. According to the laws of reflection, angle of incidence and angle of reflection are of same measure. What is the meaning of this paragraph? You can observe here this MN is spherical mirror. Obviously this center point is pole and this is center of curvature. When AQ, which is incident ray, falls on mirror, AQ falls on mirror, at that time QB is coming out mirror, that is a reflected ray. AQ is incident ray and BQ is reflected ray. Between that, whenever we are drawing a line from C to Q, that is radius of curvature, it is creating an angle between these two rays, incident ray and reflected ray. So these two angles are equal, incident ray and this. You can observe here AQC is the angle of incidence. AQC is the angle of incidence. According to the laws of reflection, angle of incidence and angle of reflection are of same measure. So whatever measurement of this angle, that much measurement of this angle. This one we can say it as angle of incidence and this one we can say it as angle of reflection. Thus, while drawing the reflected ray QB, angle CQB must be equal to angle of AQC. We can write this way: angle AQC is equals to angle BQC. Okay. So, in this way we can draw the reflected rays. Whenever we are going to draw a ray diagram of any spherical mirror, we have to follow few rules for incident ray and reflected ray. So rule number 1 is, in an incident ray is parallel to the principal axis, then the reflected ray passes through principal focus. Suppose in the diagram 1 you can observe a spherical mirror is over here. This blue line is incident ray. Whenever the incident ray is parallel to the principal axis, so whatever reflected ray that is passes through the principal focus. So principal focus is in between center and pole. Okay, so I am repeating again. If the incident ray is parallel to the principal axis, then reflected ray passes through the principal focus. You have to learn this statement. Okay, this rule 1, rule 2 and rule 3. Then you will get it very nicely how to draw ray diagrams. Rule number 2 is, if an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. Suppose this blue line, second diagram, you can observe here this blue line which is incident ray. Whenever incident ray passes through the focus, then its reflected ray will be exactly parallel to the principal axis. Okay. Next rule is, if an incident ray passes through the center of curvature, the reflected ray traces the same path back. You can observe here with this third rule, if the incident ray passes through center of curvature, then the reflected ray will follow the same path in opposite direction. Clear? If the incident ray passes through the center of curvature, then its reflected ray also pass through the center of curvature. These are the rules for drawing ray diagrams, which are very, very important. Please keep these things in your mind, and this is part of your homework also. I am writing here. You have to write this 3 rule as a homework, and you have to draw this diagram itself. You have to learn these 3 rules also. Then you will get it very nicely. Now we will discuss images formed by concave mirror. We are having one experiment. Through this we can clear images which are formed by concave mirror. For the same we need material, that is candle or glass lamp, 2 cardboard boxes, large cardboard sheet, white paper, concave mirror, meter, ruler, wooden block. Procedure is, take the cardboard box large enough to hold the candle or lamp. Cut off one side and place the candle inside. You can observe that arrangement with this diagram. This is cardboard box. Inside that we kept candle. Cut out a narrow shaped slide from one side so that we get an arrow shaped light source. Here you can observe in this figure. Make a screen of size 20 by 30 cm by sticking a white paper on the cardboard sheet. We have to make a screen with a white paper and it vertically with the help of wooden block. What we have to stick on the white paper on wooden block. Fix the mirror vertically on the other cardboard box by making slit its top surface. You can observe here we have attached concave mirror. Place the screen near a window and place the mirror in front of it such that image of the sun or some far away from the object forms clearly on the screen. Measure the distance between the screen and the mirror in this situation. This is focal length of the mirror. Why here they are saying focal length of the mirror? Because we are choosing an object from infinite distance. If the object is coming from an infinite distance, then its image you are getting it like it is a very diminished point type of image is there, so it comes on focus, and that is focal length of the mirror. Set up the experiment as shown in figure. A dark room. Place the mirror near 0 mark meter scale. Place the screen in front of it. Place the light source between the two so that the distance between mirror and source is little more than focal length of the mirror. Obtain a clear image of source on the screen by moving the screen along the meter scale and perpendicular to it. All these things I will show you in the video. Now I am reading it. Please listen carefully. The image will inverted and larger than the source. As the image is obtained on the screen, it is real image. Now move the source away from the mirror so that distance between the two is greater than twice the focal length of the mirror. Get a clear image on the screen moving towards the mirror. The image is inverted, smaller than the object, and it is real. So here is the diagram for the same. You can observe here. Here we are taking a concave mirror. This is your concave mirror. This is principal axis. This one is the focus. This is here it is center of curvature. Now suppose AB is the object. If incident ray passes through the object, then if it is parallel to the principal axis, then definitely it will pass, means the reflected will pass from the focus. Now next, there are two rays. One is parallel to the principal axis and one ray is going to the focus. So if the ray passes through the focus, that is parallel to the principal axis. The reflected ray is parallel to the principal axis. Okay, so all these are in rule. So you have to read rules properly, how to draw ray diagram. If you will read it properly, then you will understand it clearly. Now after that we are getting one point, and that point is for image of the object. So this is the image for point A. What about B? Whenever a ray is passing from its center, that is coming back again. So the image you are getting at on the same line, which is B dash. When you will draw a line to join these 2 points, then you will get the image of the object, and definitely this is greater than the object. So we can say whenever we are keeping object is in between center of curvature and focus of the mirror. The object is in between center of curvature and focus. So we are getting image behind the center of curvature, and it is greater than object. Clear? Now next we are taking object is at between focus and pole. Suppose if we are taking object between focus and pole, so here AB is the object. Now this blue line is incident ray. When the incident ray falls on the mirror, at that time is reflected ray is passing through the focus. Why? Because as we have studied, if ray is parallel to the principal axis, then the reflected ray will pass through the focus. So here it is focus. So it is passing like this way. Okay. Now next, whenever ray is passes through the center of curvature, then it is following the same path. So this ray is passes the same path, and we are not having any image on this side. So we feel that the image is forming somewhere behind the mirror. You have to join these 2 points, A dash, B dash, and this is the image of the object. Again, it is greater than the object.